My name is Dang Song. I'm the founder of Oasis Labs and also a professor in computer science at UC Berkeley. So today, I will talk about the future of self-sovereign identity and data sovereignty. As we all know, data is a key driver of modern economy and the lifeblood of AI and machine learning. And more data is being collected every day, and value from personalized data now counts for a significant percent of GDP. And the global data economy is growing exponentially. But however, a lot of this data is sensitive, and handling the sensitive data has presented unprecedented challenges for both individuals and institutions. For individuals have lost control of how their data is used. Often users' data is sold or misused without their acknowledgement and consent. And a lot of this data has been sold under the premise that the data has been anonymized. However, volume of research has shown that anonymization is not sufficient to protect users' data privacy. So here's a great example, a case study done by New York Times, showing that from anonymized mobile phone location data, New York Times was able to track the location of a Secret Service agent with former President Trump, and hence knowing the whereabouts of former President Trump. So this illustrates that anonymization is insufficient to protect users' privacy. For institutions continue to be plagued by large-scale data breaches. A lot of these attackers actually steal sensitive information of hundreds of millions of users or even billions of users in a single attack. And furthermore, users' data is locked in different data silos. For example, for different applications, users' data is being locked in, and it's difficult for users to actually leverage their data across these different applications. And this also extends, this data silo problems also extends to even greater scope. So today, one of the biggest problems is that valuable data is also in institutions are also being locked in data silos and making it difficult to actually utilize all this valuable data. So all these issues, if they are not being addressed, it will only get more and more severe as we move further forward into the digital economy. And to the extent that it could even undermine our value and the fundamental rights for individuals. And hence, there's an urgent need for developing a new paradigm, what I call a responsible data economy. So what are the goals and principles of a responsible data economy? First, we need to establish and enforce data rights. And the data rights can serve as a foundation of data economy and prevent misuse and abuse of data. Second, we need to ensure fair distribution of value created from data, such that users should be able to gain benefits from their data. And most importantly, we need to enable efficient data use to maximize social welfare and economic efficiency. So a lot of these problems, as we will see in the rest of the talk, is actually caused by this different, essentially, approach and paradigm. So today, we are in the paradigm of Web 2, which is centralized and platform-centric, and hence, platform maintains control of users' data. Whereas we want to move towards this new paradigm of Web 3, which is decentralized and user-centric, such that users actually maintain control of their data. So now let's dive in a little bit to look at the key control points in the digital world. So in the digital world, users need to have access to resources, need to have access to data, and also need to be able to, for applications, need to be able to compute on data. And the typical mechanisms that are used to address all these three tasks is identities, access control, and also for computing on data is data use control. So in Web 2, all these three different tasks and mechanisms are done under centralized control in the Web 2 paradigm, where identities are managed by centralized service providers, data is maintained in centralized data silos, and also data is processed without the knowledge of the user. And hence, users are now in control of their data in Web 2. So in Web 3, we want to develop new paradigms and new mechanisms and capabilities to enable decentralized user control in Web 3. And in contrast to Web 2, what we have is, in contrast to centralized identity service and identity control, we have decentralized identity. And in contrast to centralized data access control and data management, we want to have decentralized access control. And for data use, again, instead of platform-centric centralized control of users' data, we want to enable what we call policy-compliant decentralized computation. With all these three key aspects and mechanisms, we enable user control of their data usage without relying on an intermediary. And altogether, putting together as a full stack, I call this is the essence of data sovereignty in Web3. So in order to enable these new capabilities and new mechanisms, we need to develop new technologies. And so first, just very quickly, for the identity aspect, we have moved from Web 1 to Web 2, and we want to move towards Web 3. Whereas in Web 1, users use username and password, and in Web 2, they sign in with various centralized service providers. And in Web 3, we want to enable users to maintain control of their identity by controlling their own private keys. And one of our recent work actually further developed along these lines to enable the first anonymous credential using ZK Snark to enable practical on-chain verification. So with decentralized identity, in particular, to be able to actually verify users certain attributes, the values of certain attributes, and with the privacy protection, there's this mechanism called anonymous credential, where users with this anonymous credential can actually prove certain properties of users' different attributes in a privacy-preserving manner. But however, in order to enable Web3, like dApp applications on-chain, we need to be able to enable efficient, practical on-chain verification. So by using ZK Snark, our new work called Zebra, the paper is available online, develops the first ZK Snark-based anonymous credential with practical on-chain verification. And this enables broad range of use cases, including KYC to DeFi. So this is a research work done with my students at UC Berkeley. So that's the first component, decentralized identity. Now let me quickly move on to the other two important key capabilities, decentralized access control and policy-compliant decentralized computation. So in traditional Web 2 centralized access control, the central server actually has users' data and also maintains this access control mechanism, including access control list for the users' data. Whereas in Web 3, we want to fully decentralize this. And also in order to decentralize this, we actually, in this case, will separate out the access control mechanism versus the resource, the secret management mechanisms. So given interest of time, I won't actually be able to go into the details for this. So at high level, with decentralized access control, users' data access policy is committed on-chain in a privacy-preserving way. And for a data consumer can attest on-chain to prove whether the data consumer satisfies or complies with the data access policy. And there's a separate secret management committee, this decentralized service, that maintains users' sensitive data. And from the on-chain verification that the data consumer actually satisfies the data access control policy, then the secret management committee, this decentralized service, can then release the secret to the data consumer. And this decentralized access control can enable a new suite of applications, including decentralized web application, post-mortem enforcement of a will, and also cross-domain policy-enforced document sharing in a variety of different corporate settings and other settings as well. And at Oasis, we are developing developing mechanisms actually using. We have a SDK and a set of tools called Parcel to enable this, decentralized access control. So with decentralized access control, users can maintain control of their data in terms of who can access their data. But there's one catch here, that with decentralized access control, once the data is released to the data consumer, then the user loses control of that data, because the data can then be utilized by the data consumer in any way it wants. And hence, we need a new mechanism to address this issue to really help users to maintain control of their data throughout the entire data lifecycle. And that's what we call policy-compliant decentralized computation. Again, in Web 2.0, the central platform and servers maintain control of users' data, and then they can use their data, they can use users' data without users' awareness and consent. And also, they can use users' data to gain benefits, also without sharing back the benefits to the users. So in Web 3, we want to enable a new paradigm such that users actually get to maintain control of their data, how their data is used, without actually relying on a trusted central server. So in order to achieve this, traditional solutions in Web 2 are insufficient. So in traditional solutions in Web 2, data is only encrypted at rest or in transit. And hence, data encryption can only protect data at rest or in transit. And data is either not used, or if it's used, then it's copied to the data consumer, and hence making it difficult for users to maintain control of their data. And also, as I already mentioned, anonymizing data is insufficient to protect users' data privacy. And thus, in Web 2, there's no mechanism actually for users to maintain control of how their data is used. So in Web 3, we need new technologies to, in this case, protect data in use. So this has several aspects. One is that we need to control the use of data without actually copying the raw data. We need to enable applications to be able to compute on data, essentially encrypted data, or in a way that they can compute on data without actually getting a copy of the raw data. And also, secondly, we need to protect the computation output from leaking sensitive information and ensure policy compliance for data use. And with these mechanisms, in Web 3, users can maintain control of how their data is used and also be able to audit how their data has been used without relying on any central trust. So in order to achieve this, this is actually a really tall order. So in order to achieve this, we rely on a number of rapid advancements in what I call responsible data technologies. So these different types of responsible data technologies, when you put together, they can help users to maintain control how their data is used. Because of these different aspects that I just mentioned that need to be addressed for data to control data usage. So the first one is secure computing. For example, utilizing secure hardware or cryptographic methods such as MPC, FHE, and so on to protect the data confidentiality during the computation process. And another example is data privacy, differential privacy, which protects the computation output from leaking sensitive information about the data input. With fair data learning, it can help data to remain on users' and data owners' device while still enable distributed machine learning and data analytics. And with distributed ledger, it helps provide an immutable log to ensure data usage is compliant. So I want to share a recent case study, a recent project that Oasis Labs did together with Meta for launching a large-scale, first-of-its-kind a task. In particular, in this case, is AI model fairness measurement in a fully privacy-preserving way. So this really is first of its kind, and the technologies have been rolled out to Instagram users. So due to time limit, I won't have time to go into the details how we do this AI model fairness assessment. But largely, essentially, in order to do these AI model fairness assessments, the model provider, which knows the model inference results of a user, ideally, in order to compute the AI model fairness measurement, one also needs to know the user's certain sensitive attributes, for example, user's gender, and so on, which in this case is maintained by, for example, a survey operator where the users opt in to fill out certain surveys with their sensitive information. And in this case, we want to protect users' data privacy while still be able to compute this AI model fairness assessment. And in our partnership with Meta, Oasis Labs actually developed the privacy-preserving technologies for this by utilizing actually a combination of secure multi-party computation, homomorphic encryption, and also utilizing ZK zero-knowledge proof to show certain data is well-formed, and also adding differential privacy to further protect users' data privacy. And by combining all these different techniques, we, for the first time, enable this large-scale, real-world, fully privacy-preserving AI model fairness assessment, which is also really important for societal benefits. So that's just one example how utilizing this decentralized computing and privacy computing technologies, we can help users to maintain control of their data and at the same time to enable data to be utilized in a privacy-preserving way. And at Oasis, also we are developing more advanced technologies with parcel and other extensions to enable what I call here policy-compliant decentralized computing. So in this case, data owners can specify policies how they want their data to be utilized. The policies are committed on-chain, and the data consumers, again, they have to prove, they have to be able to provide proof that the program satisfies the data use policy, and hence then be able to compute users' data in a secure execution environment or using, for example, MPC, this type of secure computing technologies, and then in the end, be able to do the computation. And the entire process is also logged on the blockchain to provide the audio log. So with this type of technologies, by combining privacy computing and blockchain, we help create a new type of assets that we call data assets. And in this case, privacy computing ensures data privacy during compute, and the blockchain helps maintain immutable log of users' data use policies, and also maintain the immutable log of how users' data is utilized. And by combining this creates a new type of asset that we call data assets. And with this data assetization, the Oasis platform can unlock a new responsible data economy where users and business can maintain data rights and earn value from their data assets. And at Oasis, we have been applying these technologies to different segments. In particular here, as an example shown for users' genomic data. And so in this case, using the Oasis technology, we help users for the first time to maintain control of their genomic data, and also at the same time to enable their data to be utilized in a privacy-preserving way. And further, to enable confidentiality and privacy for dApps, for Web3 dApps. Also, Oasis just launched Sapphire, which is the first and only confidential EVM, which is a paradigm running in a secure enclave with the EVM. So with Sapphire, it for the first time creates a truly new capabilities for smart contracts today. So today, smart contracts on permissionless blockchains, they are all public. Anyone can see there's the data and can see their smart contract states. With Sapphire, the smart contracts actually runs inside the secure execution environment, such that the smart contract state is kept in with the confidentiality. So today, you can take an existing Solidity smart contract, and in 10 minutes, in general, you can actually port it inside to run inside Sapphire, and what you get is out-of-the-box contract state confidentiality, and also automatically you get a protection from MEV, minor extraction value, because the attackers in this case won't be able to see what actually won't be able to see the payload of the transaction before the transaction is executed. And hence, you cannot front-run what you cannot see. And Sapphire also offers great scalability and low cost. and also provide stronger security and integrity guarantees as well. So in this case, in addition to break the proof of stake, for example, in a consensus mechanism, in addition, you actually have to break secure enclaves in addition to existing defenses. And hence, Sapphire system actually offers much stronger security and integrity guarantees than today's system. And again, as I mentioned, Sapphire has a full EVM compatibility. All the user-facing toolings, dev tools, they all work out of the box. And Sapphire provides new built-in functions, for example, for cryptographic capabilities as well. So as Sapphire as the first and only confidential EVM, it's easy to use and can enable developers to leverage current ecosystem while getting additional privacy protection. So actually, there's no downside when compared to regular EVM. There's only upside. So if you're running an EVM-based app, you actually should be running on Sapphire. There's actually no reason not to use it. And I want to emphasize here that the future inevitably is confidential EVM. So in the internet, we have already witnessed, we moved from HTTP, which is what we have in the beginning, where the internet traffic is all in the clear. And now there's very little HTTP. Most of the traffic is actually under HTTPS, which is encrypted. As internet usage gets further adopted, people realize the absolute need for privacy. And I would say that for blockchain, we will also be going through the same evolution. For real-world applications, privacy is absolutely necessary. And so we'll be moving from this public transaction contract states to everything is fully confidential. And Sapphire, again, is here to assist this transition as the first and only confidential EVM. And for developers, you can go to Oasis website to learn more about Sapphire. And you can try it out on testnet today. And again, taking an existing Solidity smart contract, in general, you can port it to Sapphire under 10 minutes. So with all these great capabilities, when we put these things all together, we can also enable what I call data commons for decentralized data science, where data owners and producers, they can register their data sets with policies specified for how their data is utilized in these decentralized data catalogs. And data consumers and analysts can search through this data catalog to identify data sources that they want to use, and then write their data analytics and machine learning programs over these different data sources while satisfying the desired data use policies. And the policy-compliant decentralized computing platform help provide distributed secure computing while ensuring the program is compliant with desired policies. With all this, we can enable data commons for decentralized data science and help reduce friction of data usage, remove data silos, and enforce stronger security and privacy protections. And my prediction is that in 10 years, data trust and data commons will become predominant ways of utilizing diverse sources of data, enabling ownership economy where users benefit from their data as users and partners. And in 10 years, huge economic value will be created through these new forms of data trust and data commons, orders of magnitude higher than today's data marketplace. So to summarize, I've described this full stack of data sovereignty and self-sovereign identity, including decentralized identity, decentralized access control, and policy-compliant decentralized computation. And at Oasis, we are developing cutting-edge technologies to enable all these different components. So with that, for the future of the internet, we must build a responsible data economy. And the decade of 2020 is a decade for building a responsible data economy. And we look forward to working together with the community to make this a reality. Thank you.